break. Oh my God, I was muted the whole time. This sucks. TLDR objects. We can use them we can write a class to represent a blueprint for making a thing with properties and actions that it can do. Sorry about that. For anyone on Zoom, apologies. But yeah, so again, like to clarify, we have traits here, right? A human has the age trait, it has the height trait, and these can be set. So you can create different humans that have different ages and different heights using the constructor function here. And you can call methods on it to change those properties, right? Change the values of it, or have it do stuff, right? So as you can see here, grow is a method for the object in the class. It gets called on a human object, does something to it, changes the properties a little bit. So for example, if you wanted to create an instance of the human class, create a human object, we can make James, our fabulous instructor here. Let's say you call the constructor, right, with properties, an age property, right, a height property. So we have age in years and height in inches here. And this is how you create an object that is an instance of the human class with the arguments that its constructor specifies, right? The constructor specifies you need to give it an age and a height, and we can point this object to, connect it to the variable named James, right? This way you can do like, next up, well, if James grows taller by 1 inch, we can call the method grow on this object, right? And so now if the grow method, right, modifies height by adding 1 inch to it. So now if you call for the property of the James instance of human, right, this object, and you call for its height, then you get 70 plus 1 is 71, right? Yeah. Yeah, so I can go back real quick. So notice this function here, right, grow, it's defined within the class. So then any instance of the class that you create, right, any human object you create will have a grow method built in, right? So you can make any other human. We can make Bob the human and call bob.grow. And if we use the same class structure, right, to create the object, we use the same constructor, it's an instance of this class, then yes, we can do the same method call, right? Bob.grow. And we can also go like, oh, bob.height equals whatever, bob.age equals whatever, right? Yeah, so any human you create with this template, you can think of it, is going to have the same properties and can do the same things. Yeah, does that make sense? All right, so this might seem kind of new and it might seem a little bit weird, but actually you've encountered this before. This is not brand new. So for example, when we use matplotlib, right? When we plot something, we do like axis.plot, set title, add a legend, whatever. These are all methods that we're calling, and they're methods of the axis, well, or the AX here object, right? We define that somewhere, we create it, and now we can modify it, we can do stuff with it, etc. And these are all method calls, right? That's how you like use an object, right? It has all these things it can do, and you call the method on it, it does stuff. You might want to think of some other examples of, things we might have encountered that are similar, that they're all objects really, and to do anything like modify stuff in a list, modify a list, or modify stuff in a NumPy array, right? That's all like methods of the list or array objects that were, or sorry, the list or like, similar objects that we're calling methods on to be able to manipulate them and change their properties, set new values, anything. So now that you have this context, like think back, right? Whenever you do like something dot function call or something dot method call, right? You're doing something to it. List dot append, list dot remove. You're doing something to the list. That means you're like, it basically, that dot tells you that you're taking this object and you're calling its method append or remove or grow or whatever on it, right? So if that wasn't enough, a lot of the things you guys have encountered already are actually objects. So for example, Hannah's data frame that you might use for storing data, well, you can call methods on it. It's an object. NumPy arrays, like we said, dictionaries, axes and matplotlib, I guess even like figures and stuff, right? Lists and tuples, anything like that. Like if you think back to it, right? How do you manipulate them? How do you change their properties and use them? if they look anything like that, something dot like object dot method call, then that's a pretty nice way to like tip yourself off. You're using an object here, right? And of course, since this is everything here ties back to physics or astronomy somehow, object-oriented programming can be very useful for physics, can make our lives a lot easier, so we don't have to write the same code over and over, right? That's obviously pretty nice to have because we're lazy. So for example, let's say you wanted to, do some math with vectors, right? There's a lot of operations you can do. You can add them, you can subtract them, take a dot product, cross product, whatever, right? That's a lot of work. You don't want to have to be like solving that every single time, right? But we can make a very easy way to represent vectors as an example with object-oriented programming. So for example, we can define a vector class like this, right? And well, let's just, stick to 2 dimensions for now. We'll keep it simple. A vector, right? What does it have? Well, you can think of it, it has an X component, it has a Y component, right? So we can create a vector using just these traits, right? And so that's what our constructor here looks like. And then we can define a lot of these methods that are different things you can do to this vector, right? You can add this vector to another vector. You can subtract this vector to from another vector. You can find the length of this vector, right? You can calculate it. You can like multiply it by another vector, right? We calculate the dot product, for example. And so in this way, right, it's a nice example of how you might use object-oriented programming to create a representation of something that you encounter a lot, right? You encounter vectors a lot. If you write a class for it like this with properties and methods that it can use, you don't have to repeat a lot of code, right? Now, every time you want to represent a vector, you just do like, oh, I don't know, position equals vector X position, Y position, and then you can find the magnitude of it. You can find your displacement, right? You can, add another vector and find how far you've traveled or whatever. Like, see what I mean by object-oriented programming makes it easier to represent like a lot of different things and handle them in a way when you've got a lot going on. So similarly, like more methods here, you can find the angle, right, between like the angle of the vector, right? You can find the dot product, you can do multiplication, you can do arithmetic with it, right? And an application then is like you want to solve a collision problem or whatever. Well, you can make a bunch of vector objects to represent different quantities that are changing and be able to manipulate that, right? With the vector object, right? You can just keep calling its methods, add or subtract or multiply or, get the length, right? And that'll let you do everything you need to do to, manipulate it to get the values that you want for whatever problem you're doing. Yes?
In the methods, actually self and other, are those like keywords or like how do we know what is self and other? I mean, I get that it's for example for the addition, it's just one vector plus the other one. Mm-hmm. But like how are those words?
Yeah, so we can take a look at that, right? Notice that the constructor, right, that has self as its first argument, right? And similarly for length, right, you're calculating the length of this vector object itself, right? So that keys you off to mean like the only thing you need for this method or this action is this object itself, right? You don't need any other instances of this class. It's just this one. But for example, if you're adding a vector to another vector, then what you do is the other here refers to like another vector object that you need to put in as an argument, right? So like, let's say if you wanted to do, I don't know, like you have your vector A and then your vector B, and you want to add them, the way you can represent that here is like A equals vector whatever, some xy, B equals some vector whatever, right? And then you can do like A dot add, and you take in B, right? So then what this is like self, okay, it's the A object, right? It's a vector. We are adding another vector. The other refers to B. That's not a keyword though. Self is a keyword, but other is not. Other, I could also call it vector 2. I could call it vector B, whatever, right? That's just a variable name. But like that's the other argument we're putting in, right? So if it's just self, right? Like let's say I wanted to find A dot length, I could do like A dot this, right? And I don't need to put in anything here because that just refers to, okay, the the method's being called for like this object itself, right? You don't need anything else from the outside. But the other there refers then to like another argument, right? To do this method, we need to give it something else that it can't find with just this instance of the class, right? This object, yeah.
Doing A and B changes A, right?
So actually here, notice that it returns a new vector, right? See that, like vector self dot x plus other dot x, right? So it creates a new vector object actually that is the sum of this and this, right? So perhaps I could say like, you know, vector C equals, yeah.
That's probably what we said.
Just other usually a vector to see up there, like other has x. And
Yeah.
y, so you can like
So other here would have to be another vector object, right? Notice that we're doing stuff like calling for other dot x, right? So in that case, we're looking for the x property, right? Or the x field for the other vector, right? So if you put in something else that was like totally random, I don't know, like a list or whatever, that doesn't have the x property, then Python would be like, I'm looking for the x property, right? I can't find it in this thing you gave me. That sucks, right? But if you put in a vector that has, you know, x, y properties, then that works out, right?
so is it usually gonna be in a red with two elements? Like just what's the format
For this, notice that other here is also an instance of the vector class, right? It's also a vector object. So to create it, you would use the same constructor that you do, right? At the top where you see like init, right? So that's what I'm calling here, right? Pretend I have like, I don't know, 3, 1, 2, 5 or whatever, right? Like this is how I create a vector, right? I put in an x, I put in a y for the constructor. And then now that this vector is created, this vector object is created, this is created, I can do, yeah, I can like call different methods with it, right? So like a dot add, I want to add a and b, then I would call the add method for a, right, that vector object, and I would take in b as other, right? That's my other vector. And since they're both vectors, this goes off without a hitch, hopefully. You can call x and y for both of them, and you get a result that's a new created vector, right? That's like, you know, the result of the operation. Does that make sense? Yeah. Yep.
Is there an output vector b in that object?
Yeah. So notice here, right? Oh my God, I am not tall enough. But return vector something. You see all that stuff in parentheses, right? That addition there, you're creating another vector. See that? Like you're calling the constructor, right? You're creating another vector object with these properties that are determined by like what you put in, right? So yeah, when you create something, this method, like the add method, right? It returns a vector. So then yes, if you did like type of C, right? C would also be a vector object. Because we're calling the constructor to create another vector and we return that other vector. Vector's starting to sound like a fake word now, I'm so sorry. Any other questions? All right, Megan, do you want to? Apologies. So I want to turn it over to do a quick demo on, oh my God. Here you go.
Okay, so I sent an announcement with a link to this. It's only viewable, so you can't edit it because if you guys start editing it, then everyone sees all those edits. So you can just download it or copy it and put it onto another document if you do want to make edits. But I'll just give everyone like a minute to access it. I sent an announcement on it to check B courses. Okay, so I know vectors can be quite confusing. So I made a little bit easier to visualize kind of class. So in this one, you kind of make a candy shop. So I made a class called Candy. And the instance, so the init, it takes in the self and then the name of the candy. So these are the instance variables and they apply to just that specific instance. So I set self.candy equal to candy, and then I made an inventory. So self.inventory is equal to 0. And I didn't put this in here because that means when you make an instance, you would have to set that inventory. And sometimes you don't want to do that, but if you wanted to, you could also do inventory. Okay. So you could do this if you wanted to, but I didn't. I just left self.inventory is equal to 0 in here. So the rest of these are methods. The first method I made was an add inventory. So you add the amount specified to the inventory, and then it returns, oh, the amount of this specific candy is what the inventory is. And then I also made a subtract inventory method. So it just subtracts inventory and it returns how much is in the inventory. And I also made a sell candy method. So if there's nothing in the inventory, it returns that you can't sell anything. If the inventory is less than the amount you want to sell, then it says there's not enough to sell. And then if there's enough to sell and everything's okay, then it subtracts the value. So I call the previous method up here. And when you call it, you have to use self and then the name of the method and the amount, obviously. And then I return how much is sold and how much is left over. So as an example, I made a Twix candy instance. So if I run this, oops. I'm gonna say something. Okay, so now I made a Twix instance. So if I return what Twix is, oops. It shows that it's a candy object. So if I ask what the inventory is, you want to use Twix, which is the name of the instance, then dot inventory. And right now it's 0 because I haven't set anything. But here I'm going to add an inventory and I'm going to add like 10. And when you run that, it gives you, it says, oh, the amount of Twix is 10. And say I want to sell some candy. I want to sell 5. So you call the name of the object, then you call the name of the method, and then you put how many you want to sell. And it returns this output. And I'm going to run this again so that there are no more Twix. So if you try to sell another candy that you don't have, and it says nothing to sell. And then if you have amount of candy, but you want to sell more than you need to, then there's not enough to sell. So this is really useful for like, maybe if you have your own website and you're like selling stuff, or like you have a business, you want to sell something, like using something like this is really useful because I know not everybody here is an astro or physics major. So this is also useful for that. Some more things about object-oriented programming. Each class can have their own class variables. So for example, if I wanted to say if the candy had like dairy in it, and I could say and having an attribute before the init makes sure that every single instance of that class has this variable. So these variables can change depending on the object, but this one cannot change unless you override it. So you can override this by making a subclass. So let's just say, oops. Yeah, a little bit. It's okay. And if you wanted to make a subclass, instead of just making the name like this, you would have to make a parenthesis and the name of the parent class. So this is now our subclass of Candy. So since it's a subclass, it inherits everything from the previous class. So I wouldn't have to like copy and paste all of these in there. It already has these. But for example, if I wanted to change or override anything, I could do that. So obviously, if I wanted to make, I could change has dairy is equal to true. So this one, I can change it to false. But it'll still take in all the other methods that I had. So for example, if I did, I don't know any vegan candy, but candy, and then we'll just say like candy. So we made an instance of the subclass for candy. So I could use the previous methods. So let's just say add inventory. So it adds to the inventory. So this is really useful if you don't want to repeat code, just but you have something different from the class. You just make a subclass of that and it inherits pretty much everything from that they have.
Real quick tip for some of you out there who are interested in making games or even like simulations and stuff like that. Like I know some of y'all are looking at stuff where you might have multiple different kinds of, I don't know, cards or multiple different kinds of objects that can do similar things, but maybe not all the same. Like what Megan did here in this demo is like, you can maybe think of it as a jumping off point for that, where say, I don't know, you have like multiple kinds of characters that are running around or whatever. They're all based on like, the same core abilities, but maybe one of them has this special attack and another one is just different attack or this different property, right? You could make like a super class that's, I don't know, character and then, or like boss or whatever. And then you can make subclasses that are like, I don't know, like mage character or druid character or fighter character or whatever. I don't know, I play too much D&D. But like my point being is like, if you think about it in this framework, right? Like it's a great way to reduce the amount of repetition you need to have and still be able to implement a ton of different features and like variety of things you can do, right? It's like thinking forward to some of your projects might come in handy.
Any questions on this or just object-oriented programming in general? Okay, so that was my demo. So there's still like some time left in class. So maybe get into your groups and talk amongst each other for like your group projects.
Oh God, I think it's you stop share and then